Hey there, it's Jamie, and I've been getting a lot of questions as you guys are working through your forecasting projects. And the one I'm getting the most often is how do we deal with seasonality other than using linear regression? So, what we do, the short answer, is that we deseasonalize the data. We did that, is one of our first steps. We deseasonalized our data. And then we do whatever forecast we want to do, either exponential smoothing or moving average or Holt'd method, on that deseasonalized data. And then we take our forecast and we multiply it by the monthly index, and that will return the seasonality to the forecast. I'm going to show you how to do that. So I'm starting here with my data, deseasonalized data in vertical format. If you missed me doing that, you can see it in the video from the last Zoom session. But what I did is I placed my year, my month, my visitation in this vertical format. So 2005 to 2019, then I added a gap, and I've got my years 2020, each of the months, and this is the deseasonalized actual visitation. So here I'm calling that visitation DS to acknowledge or to separate it from actual raw data. It's deseasonalized data. So the next thing I'm going to do is forecast using Holt'd method because my data has a trend. But you might, if your data is not trending, you might be using moving average or exponential smoothing here. And this step 2, will be different. But step 3, 4, and then the actual forecast will more or less look the same, except for, rather than Holt'd method, you'll sub out whatever method you're using. So step 1, the same no matter what you're doing. Step 2, I'm going to create a forecast using Holt'd method, but you might take this time to create an exponential smoothing forecast or a moving average forecast if your data does not have a trend. So to do a Holt'd method forecast, I need to calculate 3 things: the level, the trend, and then finally the forecast. The equations for each of these things are written here and explained a little bit in the book, but I'm going to walk you through them, hoping it will have it make a little bit more sense. So to start, I'm going to enter some titles in my columns, and I'm going to start with the level, then I'm going to add the trend, and then I'm going to create the forecast, and I'm going to call that forecast DS because it's a deseasonalized forecast. I'm going to make all these column headings bold. And so let's start here with the level. The level is a weighted average of actual attendance plus previous forecasts, is basically what that means. And so if you look at this formula, and the trend formula for that matter, both of these have the subscript T and the subscript T minus 1. Whenever you've got a subscript T minus 1, that refers to the previous period than the one you're in. So if I'm here in January 2015, T minus 1 is December 2014. I don't have data for that. So my first level and trend, I'm going to need to use a different way to get those. And then the next thing I'm going to do is calculate values for those 3 boxes, for those 3 cells, and then we'll drag it down. So let's start by figuring out how you get the initial level and trend when you have no data for T minus 1. The level's easy. It's equal to the actual visitation. So L sub T is equal to Y sub T in that first period when there's no data on T sub 1. The trend is just our estimate of how much attendance is increasing or decreasing from the previous period. We don't know because we don't have any information on the previous period, but I'm just going to you can do a lot of things, but what I'm going to do is I'm going to calculate the difference in visitation between my current month and the latest month, and then I'm just going to divide it by the number of months. That'll give me the average increase or decrease over the period. So to calculate the total increase, I take December 2019 and subtract from it January 2014. And then I need to divide it by the number of months. And to get the number of months, I use the count function. And I Command Shift down arrow, and I just count how many columns, or I'm sorry, how many rows I have. This is where you need to make sure you've added a space in your data. Otherwise, this will shoot all the way to the bottom and you will underestimate your trend. I'm going to pause for a second so you can see that formula. And then we'll move on. That gives me my level and my trend in the first period, our initial t when we have nothing for t minus 1. So then now, let's calculate the weighted average values of level and trend, and then let's calculate the forecast. So, when using Holt's method, like exponential smoothing, you need an alpha. For Holt's method, you also need a beta, and the beta is the factor that we use to form our weight for when we calculate our trend. So you can see here that the formulas are very similar, but one relies on alpha and the other relies on beta as the factor by which to weight the average. So level, the level at time t, here t is February 2015, is going to be equal to alpha with an absolute reference on it, multiplied by y at time t, and that's visitation in time t. So this level is based 20% on current visitation, and basically 80%, 1 minus 20% on what would be the previous forecast. Plus 1 minus alpha, 1 minus alpha, again with an absolute reference, multiplied by the level at t minus 1 plus the trend at t minus 1. And what we're going to see in a second is that the level at t minus 1 plus the trend at t minus 1 is equal to our forecast. So we're using actual visitation and the forecast, and we're weighting them. It's a weighted average of those two things. So let's take a look at the trend. It's the same idea. So our trend we're going to base on beta with an absolute reference multiplied by the difference in the level. So what is the data actually sort of trending by? So equal to the current level minus the level at t minus 1. Plus 1 minus beta, right? So 80% of this average is going to be based on the previous trend. So you can see that the difference in the levels is one estimate of a trend, and the previous trend is another estimate of the trend. Both of these are based on the data. So negative 62. All right. So then our forecast, the last thing, forecast at t plus k is equal to L sub t plus k times t sub t. All right, so to think about this, forecast at t plus k. If we're in this box, t is January 2015 and k is 1. This is a 1 step ahead forecast. So we're standing in January 2015, making a forecast for February 2015. So the forecast for February 2015 is equal to the level in January 2015 plus the trend. So we may have diverted a little bit calculating the level and trend here, but this forecast is quite intuitive. We think that our attendance next period to Yosemite is going to be equal to our current level, deseasonalized, right, plus a trend. We know that the data is trending, so we're just forecasting next period is equal to this period plus a trend. All right, 374,478. We're a little bit off. But let's drag this down, and then we will make a plot of our forecast compared to the historical forecast, and we'll get a sense of how we've done. So when I double click this button, it's going to fill in my entire forecast. So when you're doing Holt's method and exponential smoothing is similar, you really are focusing only on calculating those first 2 rows. It's 5 boxes. It's simpler than it seems. But before we can compare our forecast to the actual, we need to reintroduce the seasonal variation because the seasonal variation has been removed in this data. To do that, we're going to multiply both our deseasonalized visitation and our deseasonalized forecast by those monthly indexes that we calculated earlier. Do you remember those? We calculated them in our very first approach when we deseasonalized the data. We calculated our overall average, what the average visitation was in all of our months, excluding 2020 because it's weird. And then we calculated what the average visitation was in each month. And then we calculated for each month what percent of visitation we would typically see, percent of average we would typically see in each one of these months. So our low visitation months, here we've got January, February, March, December, our low visitation months, those numbers are all less than 1, meaning they're less than 0. There's some percent of 0, 34% of 0. And the high visitation months are 117% of average. I hope I just said that right. I might have said it wrong. This is 34% of average. We would expect to see 34% of average visitation in January, and we would expect to see 189% of average visitation in July. So we need these numbers, but we need them in this column. We're going to use that transpose trick again. We calculated the numbers on our raw data, and then we moved it to our deseasonalized data. When we moved it in our deseasonalized data, we copied and pasted special so we no longer have the formulas in the cells, and that's going to serve us well here. We don't want the formulas. So on your deseasonalized tab, highlight that monthly, all those monthly indices, and copy them. I'm using Command C. Then in our deseasonalized vertical tab, I'm going to paste special. Right click in the cell, then paste special, and then we're going to transpose. There they go. So let's just make sure everything in this column is centered. And now double check that you've got them in what appears to be a January to December. Copy, and we're going to paste them all the way down. And each time you go to paste, just eyeball that you're placing it the first one with the January. I'm going to place it down here too with my 2020 data because we're going to need it in a minute. All right. Deseasonalize data in vertical format, check. Forecast using your forecasting method of choice. Mine was Holt's method, check. Reseasonalize the data in forecast. So reseasonalizing the data starts with bringing over the monthly index, and then we're going to multiply it by both the visitation, and I'm going to call this column visitation reseasonalized, and I'm going to call this column forecast reseasonalized. And all we're going to do is take our deseasonalized visitation and multiply it by the monthly index. I'm just going to drag this down a couple of cells because I want to get the first few numbers. So just as a visual check, if we reseasonalize the deseasonalized visitation for January 2015, we just get the actual visitation number, right? We're going to confirm that by checking in our raw tab. So we'll have 128,318. And if we go back and we look at January 2015, the attendance is 128,318. So similarly, February 2015, the real attendance was 135,316. When I've reseasonalized it, I get that same number, 135,316. In fact, you don't have to reseasonalize this step. You could copy and transpose the actual data, but this is quicker. So that's why we do it this way. This is just our real numbers, right? I'm calling it reseasonalize. I could call it raw. I could call it actual, but this is just the number of people who were actually at the park. I'm going to do the same thing to our forecast. It's our deseasonalized forecast multiplied by the monthly index. So here's where the numbers kind of start to make sense, or start to look kind of interesting. By multiplying by that monthly index, we're restoring the seasonal variation to our data. So now you can see that 135,000 actually visited in 2015. Our forecast was for 136,000, right? We're not that far off. And these are in actual numbers of visitors now. I'm going to grab those two and I'm going to double click, and it's going to populate the rest of my forecast. That was reseasonalizing the data and forecast. We reseasonalized the data, we reseasonalized the forecast. And now we're going to create a chart that's going to compare the real observations with our forecast. We did that here with the Yosemite data, and we could see that our forecast, or with the linear regression data, and we could see how well the forecast tracked the actual data. Now let's do that here. I'm just going to highlight it, and I'm going to insert, I'm going to shoot for a recommended chart, and I'm going to grab this one. I want that line chart that shows historically how well our forecast and regular visitation tracked. So here we can see the light green is the forecast and the blue is the actual visitation. And I'm going to give this a label. I'm going to call it Yosemite actual versus forecast attendance, visitation, 2015 to 2019. And I'm going to say Holt'd model. This is a lot of words in that title. I just find it to be so much easier if everything you plotted is explained on the chart. And I'm going to follow that up by doing a couple little changes. I'm going to label both of my axes. You might argue that these need no label, but if you've done something weird, or you've made a mistake, or you want, even if you've done it right and you want to go back and see what you did, it's nice to know what you did. Visitation, visitors, this is month. They're labeled 1 through 59 because we've got, however, 59 or 60 months here. And then because those are all squished up against each other, I'm just going to format that axis. So I right click, format axis, and then text options. And then in my text box, there's a choice for text direction. And I want to rotate all text 90 degrees. And it's giving me not every month, but every 3 months, and that's good enough. I can see what I've done. So that is our historical forecast. We've made the historical forecast, and we've plotted it, and we've labeled everything. And by looking at this historical forecast, we can see how well our Holt'd method of exponential smoothing forecast tracked the actual data, and it did a really good job. If this comes out for you really weird and it's not tracking the data, you've probably made a mistake. It should track the data fairly well. So now that we're seeing that this method has tracked the data, we're going to move on to creating the actual forecast. We're going to do these 5 steps. We're going to start with creating the deseasonalized forecast, which we did here, but we're going to redo in the 2020 data. Then we'll reseasonalize both the visitation and the forecast, which we did. And then we'll make some comparisons. We'll revise a forecast. We'll create a plot. So steps 1 through 3 are going to feel really similar. I'm going to just grab this box and bring it down to where we're going, because I want to make sure that we've got these formulas. Okay, and let's grab this too. So as with an exponential smoothing forecast, as soon as we get past out in the future, that's what we'll call it, as soon as we get out in the future, we no longer continue to calculate levels and trends, because those are based on data that happened before, and if we get down here, we're not going to have anything here. So once you leave reality and move into the future, we only have to worry about our forecast. And so let's think about this here. Forecast at t plus k, a 1 step ahead forecast is what we've been doing, but we are here theoretically doing a 12-step ahead forecast, right? Is equal to the level at time t plus k times the trend. So we could calculate how many periods ahead we were, but there's actually quite an easy way to do it. So if we're standing in December 2019, we have actual visitation of 377,000, our level, which is based on previous attendance and trends, and we have the previous trend. So our forecast for January 2020 is t plus 1. So our forecast for 2020 is equal to the current level plus k, which is 1, times the trend. And we can drag this by adding one other trend for each additional k. So if I just absolute reference that k, or that trend, now I've got here, oops, what did I do? Is equal to, oops, that's fine, ignore me. Pause. My forecast in January 2020 is equal to the level plus the trend. Let's just leave it there, no absolute references. And then the previous one, which is the previous, if we go to February 2020, that's a 2-step ahead forecast, 1, 2. We need a level and 2 trends. Well, we can get a level and 2 trends by, there's a level and 1 trend. And then we add another trend. And then I'm gonna hit Command T. Because here I've added 2 trends. I've added 1 to get to the first and 2 to get to the second. To forecast March, I've added 3 trends. 1, 2, 3, right? You're just adding a trend each time. So you don't have to worry about K. There's our forecast. That is us making a deseasonalized forecast into the future using Holt'd method based on this equation here. I'm going to zoom out for a second so that we can see what we've done. These spreadsheets get pretty big. I'm going to drag this back where it belongs. And there you can see your work so far. Now, I'm going to zoom back in, break over. And we have created the deseasonalized forecast, and now let's reseasonalize some things. So I brought down my monthly index before, so my visitation reseasonalized. 2020 has been weird, right? We had normal January and February, and then the park was closed for 3 months, and then we've had limited visitation, and then still no data from October. But our reseasonalized actual visitation is that actual deseasonalized number multiplied by the monthly index. And I can drag that down. And then my forecast reseasonalized is equal to the forecast times the monthly index. And then I'm going to drag that down. I'm going to make all of these green. And then I'm going to spend a moment just talking about these numbers. These reseasonalized actual visitation numbers are equal to the raw data of the real visitation numbers in January through September 2020. Just to make sure you've done it right, you should double check. So I'm going to go back to the data. I'm going to focus on January 2020, and I'm going to look for 132742. Click on raw. and I've got 132,742. Then I'm also going to look at my last value, 33,671. I'm going to go back, and I'm seeing 33,671. So by checking the first and last number in this series, I'm confirming that I didn't make a mistake. If these are correct, then these are likely to be correct. So let's think for a minute what we just did. This forecast represents our best estimate of what 2020 would look like if COVID hadn't existed. So let's just make a quick comparison here to see how the coronavirus impacted visitation to Yosemite. I'm going to insert and look for recommended charts. And I like this line chart, or column chart, I believe it's called. Let's drag this up here for a second and spend a second going over our logic. Okay, so we have established that Holt'd method creates forecasts that track reasonably well with the actual data. So we used Holt'd model to forecast 2020, assuming that it also would have followed reasonably well with the actual data had there not been the coronavirus. We then plotted both our forecast and the actual visitation numbers, and we can see that the coronavirus has impacted visitation to Yosemite. It's taken it down to 0 for 3 months and then left it at much below the expected levels. Pardon me for a moment while I format my chart. So I'm going to use the same style of title I used here and the same capitalization scheme. Yosemite, actual versus forecast visitation, and this is 2020. Holt'd model. And then I'm going to make this a little bit smaller so it takes up less room. Whew. Are we done? No. We're really close. We're really close. The last thing we need to do is figure out what we actually think October, November, and December are going to look like. Are they going to look like these numbers? 415, 217, and 163? It's unlikely, right? Because the coronavirus has still limited the way in which we travel. Yosemite did have limitations on a number of day passes they were giving out. They've since stopped doing that, but California's in a shelter, we have some sort of shelter in place order right now, so we're not going to expect these numbers to be rebounding. But what are they going to do? I'm going to create another column here, and I'm just going to call this percent of expected. And what I mean by percent of expected is how did actual visitation compare to the forecast? What percentage of our forecast actually showed up? So in January, we forecasted 135,000, 132,000 came, 97% of expected. 97.8. I'm going to drag the formula down. And now we can see that attendance was less than expected in January, more than expected in February, 0% of expected in March, April, and May. And then June, July, and August, we had between 30 and 38 and 65% of expected. September dropped way down, and I worry with that number that it's going to be updated. So I'm not really going to think about it when figuring out what percentage of normal I'm expecting for October, November, and December. To calculate the percentage that I'm expecting for October, November, and December, I'm going to create an average. I'm going to calculate the average of the months that I think are relevant. So I think that the months in 2020 that are relevant for predicting October, November, and December are June, July, and August. I think that we can estimate the percent of our expected that are going to show up October, November, December as an average of these numbers. That's a safe assumption. That's about as good as you can get. I'm confident. I'm, whatever. Am I confident it's going to be right? No, but I think it's a reasonable assumption. So that's 49.9%. So I'm going to forecast in these cells. Why in these cells? Because whatever I put in these cells are going to show up on this chart. I'm going to calculate 49% of my expected, and I'm going to highlight these in a totally outlandish and different colors so that I know for sure I'm going to remember that these numbers aren't real. So in this cell, I'm going to say what I think October's attendance is going to be. I think it's going to show up to be about 49% of that forecast. And when I click enter, you'll see the answer in the cell, but also on the chart. And you see the green corner tab. That tells you that these formulas are different than the ones in the cells above us. And now my actual forecasted numbers have shown up. I don't want to leave them in blue because I want to make sure that it's obvious that these are not my real numbers. Or these are my forecasts, but they're not actual numbers. Because see how I've got visitation against the forecast? I'm going to be placing my forecast as a real number. This will require a level of explanation if you try to do this outside of this class, but it works really well in this application. So to change the color of these three bars, you click once, click twice, and then right click, and then format data point. When you click format data point, this box is going to come up and you're going to click on fill. And then you want to have color in here. There's also border, and sometimes border opens up and you might just be changing the border color, but you want to change the fill color. And pick a color that's real obvious. I'm a fan of brick, so it's getting to be brick. And then I'm just going to do the same thing with this one, November, and the same thing with December. So here I now have my forecast. Using Holt'd method on deseasonalized data, which I've then reseasonalized, I've confirmed that Holt'd method tracks the data pretty well. So I then felt comfortable forecasting 2020 as though there was no COVID using Holt'd method. After doing that, I plotted my actual visitation against my forecasted visitation, and then I calculated what percentage of my expected visitation I saw in each of these months. To estimate what I thought was going to happen in October, November, and December, I looked at the months that had happened in 2020 that I thought were likely to be indicative of what was going to happen for the rest of the year, and I averaged them. I then used that average to calculate my forecast as that percentage of my non-COVID forecast. And so that's what I mean by I've used the actual data to update my forecast. And I've placed my updated forecast in these boxes, and I've plotted them on this graph. So we've got the so what moment coming. And to do that, I'm just going to take you over here to the comparison I did when I did the linear regression. Sorry, just kidding. It's here. Where are my charts? There we go. So when I created my forecast using linear regression, I came up with these numbers. I thought that my forecast in October was going to be 24,536. For November, 121,562. And for December, 101,768. To finish this out, I'm going to add my forecast from Holt'd's model. I'm not going to copy and paste because then I won't be able to see what I did later. I want to leave a trail. So I'm going to grab my forecasts. And then I'm going to drag that forecast down. And now I can compare the forecasts made with linear regression and with Holt's model. They're actually quite close. If I were doing this for the National Park System, I might even say I'm expecting, a number in that range for October, or a number in this range for November, or a number in this range for December. And to just make one last comparison, I'm going to copy and paste these charts into my linear regression forecast. There's the first one. Charts are slow. I know it's there. I'm going to copy it even though I can't see it. And then I'm going to pause for a second and zoom out while I wait for everything to show up. I want to show you a trick if I haven't showed you already. See how these aren't exactly the same size as the ones, the Holt's model one aren't exactly the same size as the linear regression. If you click on a chart and go to Format, over here it'll tell you the size, 2.92 by 5.5. I'm going to change that to 3 by 5.5, and then I'm going to make all of my charts 3 by 5.5. And then they will all be the same size. Which is really nice if you need to put charts in a document and you want them to be formatted the same. It's this brilliant thing. It's kind of a harsh reality. If you're using tables and you're putting them in a document, they have to be formatted perfectly and they have to all be formatted the same. That's one trick to help them get formatted the same. If I were going to put this in a document, I would readjust all of these titles so that they convey the same, so they conveyed the information but all looked alike. What I see when I look at my forecasts is that I came up using two forecasting methods. I came up with really similar results. And that both underscores the fact that I probably didn't make a mistake. And it also gives us a range. We've got two methods that did a reasonably good job tracking the data. And if my methodology is correct, we are expecting Yosemite visitation to look a little bit like this for the rest of the year. Okay, that was a long video. Thanks for bearing with me, and happy calculating.